So hello everyone, today we program the LCD. Right down we have the LCD. It's 16 by 2 LCDs we have in our workshop. It's pin numbers, and here it's 1 to 16. It's a GHD162A model. It's like this. This is the front view of this LCD. So today we hope so that we program it successfully and writing one program for it, and we are using this type of microcontroller. It's a 40 pin atmel 8089 S52. We put the program in it and write down the engineer Ramit Dhiman's LCD. We have similar type of LCDs also. So we take down one piece of this LCD. It's a yellow color LCD. So here we use the key software for programming it. Here it's a program for it. It is written by me, and here you can see engineer Ramit Dhiman, which is shown on this display of this screen. So we use the Proteus software for this. At the end of this video, we hope we understand what is behind the microcontroller working and how does it work. When I press the run button from here you can see it's the LCD that is like this. Is the simulation model of it. Here you can see the different pin configurations for it. There's no anode and cathode for LED. It's a 14 pin, and here it's a 16 pin. So we have these connections right down. The reset pin is connected to port number 3 and pin number 3.2, and right pin is connected to 3.3, and enable pin is connected to port number 3.4, and the data pins from least significant bit to most significant bit. We use the LSB at the pin number 21 or port number 2 to port number 2 to port number 2.7. It's 8-bit mode, parallel mode for the LCD. So here is the crystal clock configurations. We use it the 12 megahertz at the frequency of 12 megahertz. So here's the program, and here's how it shows engineer Ramit Dhiman written on it. So today we discuss the program. So at first we have the library including function. It's hash include register 52.h for the microcontroller, which is for 8089 S52, as this microcontroller's name's library is register, and the 52 is the model number, and .h is the include library for it. And next number, line number 2, here the line number, these are the line numbers, not for actual programming. It's the reference for any mistake. If you have similar problems like errors in this program, you can contact atmel numbers anytime. And if you have the lines on some lines errors, so number 2, here we have the hash. The pound sign is used for the definitions or writing the starting include libraries. So right now we define the display port number 2. Port number 2 is used. Data pins is connected to port number 2 on the microcontroller, and here the port number 2, as we can see from our port number 2. Here we have the port numbers, and here's the book I have used as a reference for my C programming. Is the 8051 microcontroller and embedded systems by Muhammad Ali Mazidi and Janis Gillespie Mazidi. It is the best book for the microcontroller programming. So at the chapter number 4 we have the input output port programming. At this chapter we see the atmel controllers pin descriptions. Here we can see it's the port number. Here it's the view of it. For better understanding purposes we use this. So when we connect the data pins, so we connected the data pins on the port number 2. So if we define the display port number 2, it's port 2 is on this side. This is port number 2 and these are the 4 data bits. This is similar to this, and here we have, this is the port 2. The LCD is data pins like this. Here we have an LCD. This LCD's data pins are from 14 to this is connected to port number 2, and the third line on this is S bit reset is port 3.2. Here is the 3.2 and 3.4 and 3.5. Write pin on 3.3 and enable pin is 3.4 is connected, and from where the S bit comes from. So set bit is used, S bit is used when we use the single pins of the port number, any port number, and when we write the S bit, it shows that we use the 1 bit of it, and it's used as a bit manipulation. So next, and the line number 6, we have the void, and the programming is start, and we use the millisecond delay subroutine on this. So we use the void as a function, and void is the starting and millisecond delay. It's a delay routine for using it, function for creating delay in milliseconds, and we use this, and it is the programming sign. It's I and J using as a unsigned, so it does not have any sign on it, so it's unsigned. As we have the plus or minus, I used signed bit, signed as we consider it, and signed, it's now it's unsigned, so we use the unsigned configuration. So we use the for loop here for creating some delays. For and for I and J, we have 2 integers, so it provides the delay in the program. So we use simple C programming for it, and next we use the command line for the LCD when we provide the LCD. So for the configuration of LCD command, we have some rules. So at the chapter number 12 we have LCD and keyboard interfacing. So at page number 300 or 301 we have some rules for sending commands. Here you have the RS, RW and E pins for it. Here you can see the rules and read it carefully when using this as a read or write. And here's the list of command instructions. It's DB7 is the pin description for the LCD we have using. So for sending the command, we have using this LCD command codes like this, as you can see from here. So for sending the commands, like in this program, we send display port, which is the display pin number P2, port number 2 data pins. We send the command on the display port, and for sending the commands we have rules that the reset register select RS is stand for register selects. So for sending the command, it is set to be if RS is equal to 0, the instruction command code register read selected. So for selecting this command register we use 0, and for sending the data we use 1. So here we use the command for register select is 0, and also the read or write operation, we use 1 when reading and 0 when writing. So here we use RW is 0, so RW is 0, so it means it is writing mode, so we place it in writing mode. And here's also for the enable pin. You can see to set the enable, we use the data description pins. We have here, we have enable, so for enabling it, for latching the information from it, we use 1, and for holding the information we use 0. So we information latched over here is 1, after some millisecond delays it will be 0. So here is the programming close from here, and the next programming for data, it's void LCD data. Here we have LCD for commanding, which means initializing the LCD from writing the entire command starts from here. And next, after commanding it, here is this subsection is used for command purpose. We give the command to some, we have to write some data on the LCD, and here is the data starting. So we have the void LCD data unsigned character display data. So this means there is no signs in the data, it's unsigned, there is no plus or minus, so it's unsigned. Here we have display port as, so display data means data display on the display port number 2. We use the display port here, so we display the data on the port number 1, port number 2, on the data pins of the LCD. So when writing 1, RS is equal to 1, so register select is equal to 1, which means the data is register is selected and the LCD is ready for getting data from you. And the read or write pin also 0 means we have to write something on the LCD. Enable pin is also 1, and after millisecond delay it also backs to 0. Here we close the void section for display data. So on pin number 30 there is another program which is LCD initializations. So without this program to a command or display, there is no LCD initializations basically. So for this we have to say the program that we use 16:2 LCD. So here we have the command codes for it. At first we have the LCD command. So without the command section write down, this program do not works. So we write down the commands on this, and now we have original programming right there, and this is the substantial section. So we produced first line as this is the 16:2 display, 2 line 5:7 display matrix. So this is comes from here. We have number 38, 2 lines and 5:7 matrix. First we have say that the microcontroller, it is the LCD, and there is the delay for 10 seconds. And LCD command 0x0 F. Here we have used this display on cursor on. So as we see here at my simulator, as first we see, first we have display on and the cursor on. So at this stage, at first this command runs, and after millisecond there is command LCD 0x01. So 01 means clear display screen. So when we put down, this clears the display and enables the blink sign. And after that we have LCD command 0x81. 0x81 means for second line. If you use 80, it starts from first position. If we use 81, it's from second position. If we use 83, it's from third position. As you can see, when we start this out, it starts from position number 2. And here we here's 1, here's 1, here's 2, and here's start from 2s, because we have space, place space on it from first left side. So millisecond delay, it's command line is closing, LCD is initialized, and here we have the main program for it. Here we use the unsigned character A. So void main means it's a main program, write down, which is produced on the LCD, display on the LCD. Unsigned character means there's no signs. Here it's a string for 15 numbers, as there is 50 alphabets, alphabets. So we have the second line, it's ramit dhiman engineer ramit dhiman. It's 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So we provide the 15. If we down the 14, it says it's an error of bound string, so we use 15 on it, never use 14 or anything else. We also use 16 on it. So here we initialize it integer, it's small l is equal to 0. L is for creating the while loop. So we have the while loop file from its value is equal to 0 or not equal to 0. LCD performs the data from L from position 0. Here we use L++ at millisecond delay, so producing back to back after some delays this program again and again. So here's the program, and in our next section we provide the hardware and produce the program in this microcontroller.